Okay, so now we're looking at inverse variation, right? An inverse variation is a variation, all right? But what it means is as one value is increasing, one is going up, the other is going down, okay? So it looks a little different. You have y equals a constant, right? But instead of the x here times the constant, you're divided by the constant. The x is in the denominator. Okay, so this would be an inverse variation. The x is on the bottom, and then you have y up here. All right, and what that means is as x gets bigger, right, as my denominator gets bigger and bigger and bigger, my y value is going to get smaller and smaller and smaller, all right? And if I was to get that constant by itself, all right, I would multiply both sides by x, right, because that would be and that's in the denominator. So I would divide, and that crosses out, and so I get x times y equals a constant, all right, and that's that. So with an inverse variation, you multiply x times y, and you get the constant. All right, so you're going to multiply x and y, all right, for an inverse variation. So I have x times y equals x times y, all right? Because as one gets bigger, the other has to get smaller so that they stay constant. All right? But it's not just bigger and smaller. They have to actually, when you multiply them together, they have to give you the same number. So here we have y varies, and you look for these key words inversely. All right? Inversely as x. So I know that I'm going to have varies inversely, y equals some constant divided by x. That's what inversely means. And then you look at what you're given. Y is equal to 18 when x is negative 3. Okay, so I can substitute in for y, and I'll put a 18 equals the constant over negative 3. So my y, when y is 18, x is negative 3. All right, and then to solve that, I would multiply both sides by negative 3. Oops. All right, so those cancel out, and I get k equals negative 54. All right. Now, so that's the constant. The constant is, k is going to be negative 54. So I'm going to substitute into this equation. So I get y equals my constant, right? This was k, negative 54, divided by the x value. Well, x was negative 11, so I'm substituting. Alright, so first of all, I write my inverse equation, then I solve for my constant. Alright, and then I'm going to substitute in. Alright, and then I'll get my answer. So I know that k was negative 54, so I substitute that in. And I know that x was negative 11, so I'll put that in there. Right? Another way you could look at it is with the multiplying. You know, if you multiply x and y, you also get a constant. So I know that if y is 18, x is going to be negative 3. So when I multiply them together, I get my constant of negative 54. Right? And then substituting back into the original, right? Then going to once I have my constant, then I can go back to the original and say, okay, negative 54 equals negative 11 times some y, right? And then I would divide both sides by negative 11. And I would get this for my final answer. Because a negative divided by a negative is positive. That was all very cramped, so let's do one where we can see everything. So if y varies inversely with x, all right, so I know I've got y varies inversely with x. So y is on top and x is on the bottom. Okay, that's inverse, all right. I also know I could say x times y equals that constant. All right, and I know that y equals 2, you look at what you're given, y equals 2 when x is 25. All right, and I want to find, so if that's true, right, if y is 2 and x is 25, I know that if I multiply them together, right, 2 times 25, that's going to give me my constant, right? I know x times y equals my constant if they're varying inversely. All right, they're inversely related. So I get 2 times 25 is 50. So that would be the constant. All right, but what it says here is find x when y is 40. Okay, find x when y is 40. So I could say, all right, so y is 40. So if I use this equation, I'll say, all right, y is 40, the constant is 50, and I'm trying to find x. All right? And if I had, anytime you have something like that, it's helpful. I could say, oh, well, whatever, go ahead and make that into a proportion, and then we can cross multiply. So I'll get 1 times 50 is 50, and 40 times x is 40x. All right. And it kind of puts me back to this original, this equation where I have x, right? This x and x times y here, and this x and this y multiplied together are going to be the same constant, right? Because this was 2 times 25 is 50, and then 40 times x. All right, and then I'll divide by 40. So 40 divided by 40 is x, 1x, and then I'll divide this, 50 divided by 40, and I can do that on my calculator. So I'll take 50 divided by 40, and I get 1.25. All right, so x is 1.25. So my y's went from 2 to 40. All right, so the y's went up, right? But the x's went from 25 to 1.25. So the x's went down. Right, and that's what happens when the x and y vary inversely. One goes up and one goes down. You can check out on the table as well. Okay, if you have an inverse variation, all right, you have, if one goes up, right, one is increasing, the other one is going to be decreasing. But if it's inverse, remember x times y is going to equal that constant. So you're going to multiply. All right. So looking at this table, I have 2 times 10 is 20. 4 times 5 is 20. 5 times 4 is 20. And 20 times 1 is 20. So do they vary inversely? Yes, they vary inversely. All right, so the x's are going up. They go from 2 to 20, and the y's are going from 10 to 1. They're going down. X's are going up, and y's are going down. But you have to look at more than just that. You have to make sure that when you multiply them together, you get this constant. You have to get the same number, not just up and down. Okay. So for a direct variation, we're going to divide, right? And you have this, right? You're dividing y divided by x and y divided by x. For inverse, you're going to multiply. So you have x times y equals x times y. All right, so let's check out this one. We've got y varies inversely with x. Okay, inversely with x. So I know x times y equals x times y. All right, and then I'm just going to substitute what I've got. These go together. Y is 12 when x is 2. So 12 times 2 has to equal, well, I don't know what this y is, when x is 8. All right, so I have y times 8 equals this, right? So that'd be 24 equals 8y. So I'll divide by 8, and so y equals 3. 24 divided by 8 is 3. Okay? So again, we can check our y's went from 12 to 3, so the y's went down, right? And the x's went from 2 to 8, so the x went up, all right? At that same constant of 24. Both sides, my constant here is 24, because if I multiply 12 times 2, you get this 24. That's your constant. All right. And then our next example, we have y varies inversely as x. Okay, so same thing here. We have I have x is 18 and y is 6. So if I multiply, I could say, if I multiply them, so 18 times 6 gives me the constant. All right, so that would be 108 is my constant. All right, and then we're trying to find y when x equals 8. So I have y, I'm trying to find, and then equals my constant over x, right? So y equals 108 over x. Oops. Oh, which is 8. $108 over x, right? Because I know. And then we're trying to find y. It says find y. So I've got y by itself, so I'll just take 108 divided by 8, and I'll get 16. 108 divided by 8. Right, so we'll just do that on our calculator. 108 divided by 8. We get, 13.5. Okay, and I could check myself. I know that, these two have to multiply to be 108. So 8 times 13.5 needs to be 108. All right. So here it says you've got these are ordered pairs. All right, it's hard to tell, but there's a comma. So ordered pairs means you have an x and a y. All right, that's an ordered pair, an x coordinate and a y coordinate. All right, and they're inversely related. So how do I find the constant of variation? Well, I multiply the x times the y. So if I look at this guy, all right, so that would be 1/2 times 10. Well, 1/2, what's half of 10 is 5. So that is my constant of variation. That would be my k. Okay. So for inverse variation, you multiply. Direct, you divide. Good work.